Okay, we are recording. So, welcome to this tutorial, which will be on oscilloscopes. So, for those who are not in my section or any of my sections, my name is Dr. Hemmert, and I am the instructor for section 0302 and 303 for Lab 1 at Texas Tech University. So on this tutorial, we will be looking at how to use an oscilloscope. This is basically a beginner's type guide. I give you a basic overview and a few tips and whatnot to actually be able to execute and use the most useful tool in your quiver, per se, in the lab. Okay, um, so let me go to the presentation. Okay. All right, and let's see. You all can see the oscilloscope reading, hopefully, so you all can see this. All right, so basically, the oscilloscope is your most important tool in the lab. And a key thing to remember is when you use this tool, it's got lots of different things and components. You need to test your scope to make sure that it is working properly. Okay. Um, all the scopes do have some type of a calibration signal on them. You need to check it. So when you first turn on your oscilloscope, you need to turn on this signal, attach it to your probe, and make sure that your oscilloscope is working properly. Normally, this calibration signal is something between 3 to 5 volts. It's a 50% duty cycle square pulse at but at 1 kilohertz. And it all depends on what the model is as far as the voltage level goes. Now, I will tell you that there is one scope, there is one brand of scope in the lab, in Lab 1, that does not have it operating at 1 kilohertz. And even worse, it doesn't even label what it is, so you have no idea what it is. It's something like 1.3 or something kilohertz. You have to look into the user manual to figure it out. So if you check out your scope and you have some goofy frequency that's not exactly 1 kilohertz, you may have that scope. So you'll have to check out the actual frequency, especially if it's goofy and there's nothing written by the calibration basically outputs, then you've got that goofy scope. But normally you are going to have a output of 1 kilohertz. And like I said, somewhere around 3 to 5 volts. 3.3, and 5 volts are probably the most common. You can see as low as maybe 2 volts or 2.5 volts. But those are usually the different voltages you'll see for an oscilloscope. Now, when you are actually preparing to use an oscilloscope, the most important thing you need to do first is figure out what kind of a signal are you going to be looking for. And that's what's shown here is basically you have some signal, in this case, a sinusoidal signal, and you need to figure out how you're going to get this to look onto this screen down here like this. So what you need to figure out is what is the voltage maximum minimum? So what's the peak and what's the trough here for your voltage? And this will help determine your voltage per division setting. Every screen typically has a total of maybe 8 to 10 divisions for both horizontal and for your horizontal and for your vertical. So that's where your volts per division setting will be. So whatever your min max is divided by the amount of squares here, and that should be about what your voltage per division setting should be. Frequency, likewise, is the amount of time you want to observe for your signal. So if you want to see 3 or 6, it all depends on what your frequency is and how much time it is from peak to peak or something like that. And that'll show basically how many peaks or whatnot on at least a repetitive, a sine wave or something like that type signal is on your screen. Then you have to determine what trigger point and slope are. Now, trigger point is basically going to turn your screen on. It's going to be basically the signal triggers this, the signal comes in, you have a trigger point, and when the signal hits that trigger point, it tells the oscilloscope, hey, put me up on the screen, and then you can look at it. So there are basically a couple things you have to consider. First off, where on the signal do you want to do your trigger? So do you want to do it down close to the bottom, up to the top, things like that? There are many different reasons to pick your spot, but you need to pick a spot. And here I've picked a couple different types of spots, spot 1 or say spot 2. Then you want to determine what type of a slope this signal is. So is it a positive or negative? When they refer to positive or negative, it's a positive slope or a negative slope, or you'll see a little symbol like this, where this would be a positive type slope, and this would be a negative type slope. If you look at this screen, in this little spot right here, you can see that that's a positive slope trigger. And you can see this is actually a trigger menu. You have a triggered, this could be externally, or this is auto, but these are the important things. You have a positive slope or a negative slope for your trigger. So it's very important, very critical to be able to trigger your signal so you could actually see it. All right. Now, as I mentioned, triggering is critically important. That's what this entire slide will talk about, specifically some of the things that I already spoke about. Now, there are different places you can put the trigger sometime depending on the oscilloscope. Sometimes it is strictly on the far left, sometimes it is in the center of your screen, but you do have a knob that you could actually move where that trigger point is. Also important, if you can't find your signal, your trigger point may be completely off. So you may just need to do an auto trigger mode so you can at least see the signal. And I'll get into a little bit more of what auto trigger mode is. But then you can also move your trigger level within your signal envelope, and then you can now trigger in what we call normal mode. All right. So let me give an overview of a basic oscilloscope layout. And this is the JYE Tech DSO138. So this is the $20 oscilloscope that I mentioned that you can buy and use and whatnot. It has a few quirks, but generally speaking, this gives a good overview of the different positions and everything on the oscilloscope. So starting from the left, and I'll go counterclockwise. First off, when you have your signal, you need to determine, are you going to look at the entire signal, which would be DC case, or are you going to look at the signal with, say it has a DC offset, you want to get rid of the DC offset, just the AC component. So that's where you would look at the AC. Ground is where you want to compare what your signal ground is to what the scope ground is. So you want to make sure that they match up, or if there's a bias there. And a good example of that is the ground here, this little arrow down here is the scope ground, but the signal ground is located here and there. And I will show you a way on this scope of how you try to get this to be the same as this, which will make your readings much more accurate or easy to do without doing some math. Otherwise, you have to take into consideration this little DC bias that you have here. So this is basically, as I mentioned, ground, AC, DC. Normally, you will almost always be in DC mode, especially in Lab 1. You should always be in DC mode. Then you have your vertical axis. This is your volts per division. For this oscilloscope, that would basically be changing the range on the left side here of what your voltage per division is going to be. And you can have here, you can see it's 1 volt, 0.1 volt, or 10 millivolts. And then you have a scaling factor here of times 5, times 2, or times 1. So you can actually go to 5 volts per division if you have this all the way to the left and this all the way to the left. Um, Now, as we come over to the right here, these are little switches that will control basically the horizontal axis and your trigger mode. And there's a couple other little things, but I'll get into a little bit more on this, on the specifics here, um, as we go around. But specific when I talk more about the screen itself. But basically, these controls are controlling this time per division. This is trigger mode. It's auto, normal, or single. This is your slope of your trigger. This is your trigger position, and this is your trigger voltage level. This shows your data as far as this is a buffer, and the little green rectangle here shows what screen or what your data is looking at screen wise compared to the full buffer. And you can actually scroll this left and right, and you'll basically be looking at all the data that's off screen here, but actually is stored in the computer. And then this tells you the status. In this case, we're holding, we're freezing our actual screen. And then down here is the actual ground for our signal. And all of these that I just mentioned, all around here, except for this volts per division, can be controlled by these switches. This volt per division is controlled on this side. Now, as we come to the top, you see this is a calibration check signal right here. For this scope, this check signal, calibration signal, is 1 kilohertz, which is pretty much the standard for all oscilloscopes, and it has an output of 3.3 volts. That's what it's supposed to be. And you can see here I'm actually inputting this into the screen here, and you can see that the volt peak to peak is 3.38. Now, this is a very cheap $20 oscilloscope, so 3.38 is close enough to 3.3 to be acceptable. So basically, this shows that the actual oscilloscope is working okay. Now, as far as the actual screen layout goes, and so this is a zoom in of the screen layout. Again, we'll start from the time you have the volts per division here. I didn't circle that, but these are all controlled by those right little buttons. You have time, second per division. You have a trigger mode. You have auto. This is a self trigger. Basically, whenever this buffer up here gets full, it just repeats itself and refills the buffer and shows it on the screen and repeats. So that's a self trigger, auto. Then you have normal mode. This is a set trigger. So you set the trigger and determine when you want the signal to actually trigger. And this will repeat whenever the buffer is full. All right. And oops. And then down at the bottom, hopefully you can see it, but there's one more trigger mode, and that's single. So in that case, you have it only trigger once, and it freezes and it holds. So it'll trigger once and then go into hold. So that's your single mode for your actual triggering. Then you have your trigger slope, positive, negative. Again, you have your trigger voltage here and where that actual trigger level is. So that is 0.58 volts. So that's, this is 0.58 volts compared to where ground is. Then you have your buffer. This is basically where your memory is stored. So all your data is stored from this bracket to this bracket. Your screen is just showing this rectangular area, which you can slide back and forth using your buttons. This is your scope status again, run and stop, hold. And here again is basically this is the channel. So this is your channel ground indicator. And on multiple channel scopes, you could have 2, 3, even 4 of these shown, and you can have them in different positions or in the same position. Okay, so buffer, let me get into a little bit on the buffering and triggers. So this is a zoom of that top of the screen, as you can see. So this is a storage buffer, and this is the actual screen. So if you consider these to be memory slot positions in memory, in this case, 32 points to make it simple, what you have is basically the scope is always reading these around and around and around. So for an auto trigger, it's always going to trigger here, and then all the information time-wise after that is going to be output, spit out here. So you can have basically position 1 all the way to position 32 would be here, and your screen in this case would be looking at, say, position, whatever this is, 9 to position 24 or something like that. So that would be this position here. Now, if you choose normal mode, normal or single point, this will float as far as where this position is in this buffer. And different screens will, or different oscilloscopes will show this in different ways. The oscilloscope I just showed you will always put this trigger at close to the front here. It's not quite here, but here, and then all the data after that, all the way around to here, will show in this basic saved buffer or saved memory. And then you can scroll the information all the way around with the basically moving this screen portion around this buffer zone. So that's, if you have a scope that has this on top, that's how you can read this. Not all scopes will have that. I'll show you an oscilloscope that doesn't have that. The data that you see on the oscilloscope is all the data there is available to you. Okay, so and this is that oscilloscope. This is the Tektronix TDS 1001B oscilloscope. It's a lunchbox, what we call a lunchbox oscilloscope. And you can see, again, this is a more complicated oscilloscope, but I want to show you it has the exact same type functions as I showed you on the previous cheap $20 model. So this is a $1,000 oscilloscope, and it has basically the same functions plus a bunch of bells and whistles as that $20 oscilloscope. So you have your screen, and obviously you have things like voltage per division and time per division. You have a slope here with the trigger level for your trigger slope. And you have a very nice signal here. Now I want to mention real quick is this is actually a good looking signal because you're filling up the full screen and you're putting on about 3 to 5 of the iterations, so it's very clear what the how repetitive your signal is. Now as we go around again counterclockwise, you have your actual signal. This is the ground, AC and DC, that you control with this menu here, these buttons. You can control the vertical axis, voltage per division, with these. So this is your vertical position knobs that you can work with. And the menu buttons, you push the menus, and the menus are going to pop up here, and you have these push buttons to basically make selections. You also have your calibration check signal right here. In this case, it's a 5-volt, 1 kilohertz square wave, 50% duty cycle calibration signal. As we move to the right, we have the horizontal axis. This controls your time per division, seconds per division. And then you also can change the horizontal position. This will actually change where your trigger position is. That's this little arrow here. And then you have your trigger modes. So you have your trigger modes I mentioned before, and the mode would be single, and that's going to be in this trigger menu. That's going to be single, auto, or normal. In this case, it actually has a special single mode that you can press so it'll only fire once. You also can, within the trigger menu, choose your source. So this has 2 channels on it and an external trigger. So you can choose your source to be channel 1 or channel 2 or external as far as what you're triggering off of. The previous scope I showed you always triggers off of the incoming signal. Now you've got all these other cute bells and whistles here as well, where you can do saving, you can print, you can do some different measurements and acquiring, you can work with your display, things like that. And you even have a little print button. So these are all the nice bells and whistles that the earlier scope I showed you don't have. But generally speaking, all these scopes have the same type operating type systems. So this is basically what you in Lab 1 would have to worry about as far as your settings would normally go. So for horizontal menu, you're looking at a DC coupling, your bandwidth is off. Um, your probe setting would be for 10 times probe. You're looking at an impedance of 1 mega ohm. If you do have no option, normally the option is going to be 1 mega ohm or 50 ohms. If there is no option available, you basically assume 1 mega ohm. Both oscilloscopes I showed you do not have this option. They are both 1 mega ohm oscilloscopes. You can invert your signal, but keep that off. For your trigger menu, you want to use your type to be an edge or peak detect. Your source will be the channel you're measuring, so it'll be probably channel 1, maybe channel 2. And your slope will normally be rising and your mode will normally be normal. You, you can use a single shot for a snapshot. All right. So that's the basics on the oscilloscope. What I want to show you now is, let me stop sharing this, and I am now going to show the camera. So where's my camera? There it is. All right, and we'll share that. And all right, hopefully you all can see this oscilloscope. So actually, I want to go through some of the different actions you can do with this oscilloscope. So I may get a bit louder or whatnot because I'm going to be reaching over this to go over it. But your oscilloscope, again, here's your screen. Here's your volts per division with your menu. And you have actually a vertical position. This vertical position will change basically the positioning of this. And then you have your horizontal position, your times per division. This is your trigger menu again, and then all the cute bells and whistles. So I'm going to turn on channel 1. And as you can see, you have DC coupling. I can scroll through this. AC, if you notice, AC basically moves the signal so that it gets rid of that DC offset. And if I change it, you can see that the AC basically gets rid of that DC offset. And you'll see that there's also a bit of a incline now on the top. It's a little hard to see, but on the top and the bottom, because it's getting rid of that DC offset. If I then go to ground, the ground is good. That's not a problem. We go back to the DC again. Now it has a DC offset of 2.5 volts. And when I get rid of the DC, it drops down. And now you've got basically what looks like just the a square wave, kind of like a sine wave or something like that. So we'll go back to DC. Bandwidth limit is off, so we're not worried about that. Our volts per division, it all depends. Probe, this is our probe. So our attenuation, we can go change that, and that all depends on the probe you're using. In this case, I'm using just 1. So that is the channel menu itself. And as you can see, I can, if I press it, I can actually get rid of the signal or I can bring it back. Now, this knob at the top allows me to move the position down or up. And then again, volts per division. So I can change, basically, make it take up the full screen or half a screen. Half screen may be good if I want to add channel 2 and I have something on channel 2, but I want to look at separately from channel 1. I can have channel 1 and channel 2 separated. Or I could actually take channel 2, match it up with channel 1, and if I want to do a comparison, like a crossover, say like a comparator would do, and you want to see when channel 2 is triggered compared to channel 1, you could actually lay them on each other. Some of the scopes are multicolored, which takes an advantage because now you could actually see that it's hard to discriminate between these two on this scope because they basically have the same color. but I'll get rid of channel 2 and we'll take channel 1 back up. Again, on this side over here is our time. So we can change our seconds per division, and basically so we can zoom out on our data, or we can zoom way in. Okay, so we can see high detail, or we can basically see multiple, just a couple iterations or whatnot of the signal. As far as the horizontal position goes, you can see this basically slides it left and right, and that's because this is the trigger spot. This is when it's triggered, and I can move that position around on this scope. You can't move it on all scopes, but you can move it on this scope. And then you have of course, you also have a horizontal menu, although you don't really need that here. It does have a window zone and whatnot. So you can look inside. This would basically be looking at a lot more detail. This is 5 nanoseconds. So this case would basically be the little rectangle within the buffer. That's basically what this is. Compared to the full window zone basically being that buffer that I showed you before. Okay, so don't need the menu anymore. Let's go over here to the trigger. And as I mentioned, this is the trigger with the trigger menu. So I'll bring up the trigger menu, and you can see the type of trigger. They have edge, they have a video type, pulse type, and basically you want edge or peak detect. This shows different sources right here. Source channel 1, channel 2, external 5, AC line, channel 1. Basically, because there was no signals coming into channel 2 or whatever, it was all doing auto. Slope, it has a rising slope, as you can see down by this little indication down here. You can do fault or rising. Mode, there's auto mode, normal mode, and on this one, if you want to do single shot mode, that's what we have here. And so that's basically, and then you have, of course, you have your coupling. You have DC, noise reject, high frequency, low frequency reject, AC, but our coupling is going to be DC, so we keep that as DC. So that's generally how we, and then we have all these special bells and whistles up here, like I mentioned. We also have a USB flash drive on this. So this is your basic oscilloscope. The nice thing about the calibration signal, this calibration signal, is now you can play around with your oscilloscope, and it's perfectly safe to do this. You can play around and you can see what all these knobs do and things like that, and figure out how different buttons do what without really hurting anything. So it's perfectly okay to do that. So this is horizontal main. Okay, there we go. Yeah, I like that one. That's what I like. Okay. All right, so that's this oscilloscope, but I want to show you a little bit with the other oscilloscope. So I'm going to go into task mode here. All right. So here is the $20 oscilloscope I just showed you. And the other oscilloscope takes forever to turn on, but this thing actually boots very quickly, which is very nice and convenient. And so as you can see, like I mentioned, this oscilloscope is a little quirky. our actual signal is really kind of off as far as here is the ground. And then you have a big difference between the ground and where the location is. All right, so that was this. There's a special technique to basically bring this into, to get the ground to actually be synchronized. Oops. What I'm doing right here is this button down here, right there. That button lets me select different portions of the screen, so I can, and it'll light up with a blue box, or it'll light up as actually blue as you go around. So this is the ground over here, which is actually blue right now. Now that's the time per division, and then the auto, now the slope. Now that is the trigger level. This is your data buffer, that's your data memory window, and then back over to the ground. And what I'm going to do is I'm actually going to press the button over here, OK, and I'll hold it down for a bit. And then, well, first I need to move. What I did was I moved this button from DC to ground, and then I just hold this down, and our grounds are now the same. That's what I was trying to achieve. And let's see, we'll reattach this. We'll see how, if that changed anything. And we'll move our button back to DC, and it's off again. So let me change this back to ground again. Hold down the button. There we go. There we go. That's almost okay. That's livable. I can live with that. The ground itself, so the ground itself, I want to bring it down just a little bit so we can see our signal completely. Okay, so as I mentioned, you've already saw what I did. I have the ground, I have AC, and I have DC over here. So when I manipulate those, the AC gets rid of that DC offset, just like the other oscilloscope, and then the ground brings that ground right down there, and then we're back up to our original signal. Then we have, again, we have our volts per division, and right now, and that's 1 volt per division right there, and then we have multiples right here of ×2 or times 1. And I'm going to leave this right there at ½ volt per division. Then we have, as we come over here, we have a reset button. And the reset button is really nice because if anything goes goofy, with this oscilloscope, you can just hit the reset button and it takes just a few seconds to boot, as you saw. And you also have this LED that you see blinking, and that's saying that it's triggered. Okay, so all I have to do is hit the reset button, and when things go goofy, and it'll come right back up, and there's our signal again. Okay, so then I'm going to take you through all the different selects again. So right now we have the time per division is highlighted, so I can use these buttons right here to basically change how much I'm looking at as far as window wise. Okay, so that's pretty simple, pretty basic and easy. Then I can move to the next position, which is auto, and I can change that from auto to normal to single. And now if you notice single, it actually went to hold, so it automatically does a hold with single. Now, if I go back to normal, and then I have to press OK to get it actually functioning again. The nice thing is, whenever I hit OK, it'll go into a hold position. So I don't have to actually go to a single to actually get it to hold. I can actually just press that OK button whenever I want. Okay, so we're in normal mode right now. Now we go to our slope. And right now, our slope here is down. Okay, so you can see that with the arrow going down, we have a negative slope. Now, if I change that, you'll see that our waveform actually changes. So you see how it changes back and forth like that? That's because I'm changing from positive slope to negative slope and back and forth. So positive slope, I am looking at and triggering when it's coming up. The negative slope is when it's going down. So this whole waveform will shift over to here when I change my trigger. Just like that. Okay. Now we go to the actual trigger level, and that's over here. And now I basically can move this up and down. And if I move this off of our signal, then we'll basically, our signal, you see how it's not moving anymore? Its waveform isn't moving anymore because it doesn't have anything to trigger off of. And so I have to move this trigger level within basically the span of my signal. And that's what I'll do here. I'll move it back up here. Okay. And I'll just hit OK again. And it doesn't want to play. That's one of the quirks on this oscilloscope, is sometimes it doesn't want to play nice, and maybe I just didn't go far enough up. There we go. Yeah, I just need to go a little bit farther. Okay. So now it's triggering normally again. Okay. And again, the actual trigger level right now is 1.2 volts. Now let me go and select our data range. So as I mentioned, the part that's listed in, shown in blue, that rectangle, is what you're seeing on the screen. But our data actually goes all the way over here. So what I'm going to do is I'm going to use these buttons to show that you can actually scan the data. So let me freeze it. All right. So now we've frozen the memory, and now I can, yeah, this is the right one. This is the right one. Okay. There we go. So you can see as the window moves to the right, the signal is actually scrolling to the left so that you can see all these things that may have happened later in your memory buffer. So things that happened at a later point. And you can scroll back. And then finally, you already saw this before, but down here is the ground position. And I can also move that for our signal up and down. So I can move it up, and I can move that position back down. So, okay. All right, so those are basically the basics on the using an oscilloscope. So let me see. Stop sharing there. So what are your all's questions? You all have any questions or anything?
I had a question
Yes.
about that oscilloscope. I just bought one. I'm actually soldering that oscilloscope you were using.
Yes.
It didn't come with a power source. Did yours?
No, you have to buy it separately.
Okay. And is there anything particular about the source that I need to know before buying it?
No, basically, it is basically this. It's just a normal lead that goes in. A lot of time when I bought mine, they had, you know how they'll have recommended to go with this item when you're buying something from Amazon or whatnot. This was actually listed with it. So that was actually listed with it.
I have one of those. I actually have two of those, so I'm good to go then.
Okay, all right. So that sounds good. Let's see. Other questions? Any other questions at all? Anything? Well then, if there are no more questions, thank you all for attending, and I will see you all in class if you're all in my class. So you all take care and enjoy, and I'll see you all next week. Okay?